This is going to be the first of 3 videos for section 5.5. We're going to begin by doing polynomial long division. We're going to divide this polynomial, this function, f of x, and you're going to divide it by another polynomial, a trinomial that's x squared minus 3x plus 5. This is example 1 in your textbook on 362, so you do have all the work right there, but I wanted to record a video of myself doing it, going really slow, trying to explain each step. I think the textbook could be a little more clear. So we're going to begin by setting this up with a divisor here. Have your divisor x squared minus 3x plus 5 on the left, have your division sign here, and then write the polynomial. Take a look at the polynomial and notice one little difference. There is a plus 0x squared term between negative 5x cubed and 4x. Like we were doing with synthetic substitution a couple sections ago, we need to write these polynomials in descending exponential order and account for all exponent degrees. So it starts with an x to the 4th and it ends with a constant. We need to include all exponent degrees from 4 down to 0, which is your constant, in this problem. So here's how we begin. You see I have 2 terms underlined in red, and we're going to be multiplying the divisor each time. We're going to be subtracting it, and we're going to be getting new terms for our answer. So I begin by taking the highest degree of exponent in my function that's being divided, so 3x to the 4th, and I'm going to divide that by the highest degree exponent in the divisor, which is x squared. You see that I get 3x squared. This is going to serve 2 functions. First of all, it's the first term in my answer. So I'm going to take 3x squared and put it in the appropriate position as the first term of my answer. I'm just going to circle that so you understand where that's coming from. The other reason I'm going to use 3x squared, and I said it's a multiplier. We're going to multiply each term in the divisor, and we're going to then subtract it from the original function. So I'm going to take 3x squared, and I'm going to multiply it by x squared. That gives me 3x to the 4th. The whole goal being here that we're going to subtract, and that term will ultimately disappear. Now I take 3x squared, multiply it by negative 3x. That gives me negative 9x cubed. Then I take 3x squared, multiply it by 5. We get plus 15x squared. Let's put a little subtraction line here, and then a reminder, we are going to subtract these lines. So as I said before, these 2 terms are going to result in a 0. I'm not even going to write a space for that. Negative 5 minus negative 9, so negative 5 plus 9 is going to give me positive 4x cubed. 0 minus positive 15x squared, negative 15x squared. Since we are dividing by a 3-term polynomial, we need to drop one more term so that I can do this whole process over again. So let's bring down 4x. Okay, repeat the process over again. I'm going to take the highest exponent term here and divide it by the highest exponent term here again. So 4x cubed divided by x squared leaves me with 4x. So that is going to be the second term in my answer, and it's going to be the multiplier for this next step of long division. 4x times x squared gives me 4x cubed. 4x times negative 3x, so 4x, negative 3x, gives me negative 12x squared. 4x times 5 gives me plus 20x. Okay, subtract. Zeros. Negative 15 minus negative 12x squared, so that's going to be plus 12x squared. It's now going to be negative 3x squared. And then 4 minus 20. Negative 16x. Drop the third term, which is negative 6. And we're going to do this process one more time. This time we have a highest exponent term of negative 3x squared divided by x squared for a third time. It leaves me with just negative 3. 2 things we do with the negative 3. That's going to go up here as part of my answer. And then negative 3 is a multiplier again. Negative 3 times x squared Negative 3 times negative 3x plus 9x. Negative 3 times positive 5, negative 15. We get the zeros. Negative 16 minus 9. Negative 6 minus negative 15, let's say it again. Negative 6 plus 15 is going to be plus 9. So now, you can see we've kind of come to the end of the road here. I cannot take negative 25x and then divide it by x squared and come up with another term to keep this process going. What you have left here is going to be the remainder of this polynomial long division process. So up here we have our answer. So the result of this process was 3x squared plus 4x minus 3. Just going back to the top so you can see it. And then we're also going to have a remainder. This negative 12x plus 9 is going to be a remainder, but it does not get added on to the end of this just as is. This remainder is still technically being divided by this polynomial expression we have right here. So the way I'm going to express it, since it's a full expression, I'm going to make it plus, and then put negative 25x plus 9, and then it has a denominator of the divisor, which was, for the whole problem, was x squared minus 3x plus 5. So it's a long process, but that is how it gets done. I wanted to walk you through it myself. That is your final answer down at the bottom right here. Okay. Next step is going to be on one more long division problem, and we'll walk our way into eventually doing synthetic division.